Today, we're going to look at section 5.4, solve problems involving linear systems. In the past few days, we looked at solving linear systems using graphs, substitution, and elimination. We also look at how we can solve one specific system by using all three different methods. Today, we're going to look at solving word problems. Before we actually look at the examples, let's review the steps involved in solving word problems. Number one is identify what is to be solved. So we need to understand the question so that we're not answering things that are totally unrelated. Number two, we identify information given to us. So just like number one, we want to understand the question, we know what is given to us, and we don't want to use them incorrectly. Number three, sometimes word problems, they give us more information than we need to solve the problem. So we need to pick out just the parts that we need for that specific question. Step 4, if it's applicable, we can draw a diagram to help us visualize the situation, or we can use a table of values to organize the information given to us so that it's easier for us to come up with the equations after. After analyzing the information given in the question and trying to get organized, we can finally write down our let statements. At this point, we know how many variables we should use to solve the question, and we also kind of know which equations or formulas to use to solve this problem. We need to communicate our approach to the question because there is usually more than one way to solve word problems. So the let statement or let statements are very, very important in telling the reader what we're going to do next. After writing down our let statements, we can write down the equation or equations next. And step 4 would help us in doing it. Once we have the equations down, then we can go ahead and solve for the unknown, the variables. Afterwards, we need to make sure that we write a concluding statement because it's a word problem. In that concluding statement, we need to state the correct units, if applicable. And we also need to make sure that we are answering what the question asks for. Sometimes, after solving the variables in step 7, we just think that is the final answer, and in the end, we didn't answer the question at all. So we have to be careful not to do that. Lastly, we want to double check our answers to see if we made any careless mistakes in the middle, or if we have copied anything wrong, or if we have written anything wrong by carelessness, and we want to fix those mistakes before moving on to the next question. So let's look at example 1. Ms. Law invested $5,500 in TFSA. She invested part of the money in a medium-risk mutual fund that paid 4% interest per year, and the rest of it in a low-risk mutual fund that paid 2% per year. When she checked her online bank account after 5 years, Ms. Law noticed that she had a total of $750 in interest. How much did Ms. Law invest at each rate? So in case you don't know, TFSA refers to Tax Advantage Savings Account. If you invest in this account, the government is not going to tax you, on the interest that you earn. Before we actually try to solve this problem, let's review what simple interest means. Simple interest is the interest that is calculated on the principal using the formula I equals to PRT. So this formula, I represents interest in dollars, P is the principal or the amount of money initially invested or borrowed, is also in dollars. R means the annual interest rate, and T is the time, and it has to be measured in years in the formula. So, step 1 of the question, we need to identify what is to be solved. So, in this scenario, we want to find out the amount of money invested in the medium risk mutual fund. We also want to find out the amount of money invested in the low risk mutual fund. Step 2. We want to identify the information that's been given to us. For the medium risk mutual fund, we know that the annual interest rate is 4%. And if we convert that into decimal form, it's 0.04. We need this decimal form when we substitute a value into the formula. For the low risk mutual fund, we know that the annual interest rate is 2% or 0.02. We also know that the total amount invested is $5,500. Step 3, we want to make sure that we're not going to use any information that is not needed for the question. When we check the information that we have, we notice that actually we need everything that is given to us to do the question. Step 4, a diagram is not applicable in this case. If you want, you can use the table values as well. However, we're not going to use it in this case because we can use the simple interest formula. So now let's move on to step 5. So for the last statement, we know there are 2 unknowns that we need to be find. We want to find the 2 different amounts of money in the mutual funds at the beginning. So we'll use 2 variables. We will be using the total amount of principal, that's one equation. We will also use the total amount of interest earned as the second equation. So for the amount of interest earned, we're going to use the simple interest formula, I equals to PRT. So let's put everything together. So let M be the amount invested in the medium risk mutual fund. So M for medium risk. Let L be the amount invested in the low risk mutual fund. L for low risk. Now our equation 1, that's M plus L, that's the total amount of principal used for the TFSA. To find the second equation, we need to use the simple interest formula. So I is PRT. So for the first part of the interest, that's based on the medium risk mutual fund. And then we have the second part of the interest earned from the low risk mutual fund. And that's why we're going to add the 2 parts up separately, and that total up to $750. So for the medium risk mutual fund, P is M, R, the interest rate is 0.04, and T is 5 years. So that's why we substitute 0.04 and 5 into the simple integers formula. And we get m bracket 0.04 bracket 5. Okay, so that's multiplication of the numbers with the variable. So that's our first term. The second term, then we have the low risk mutual fund. So the principal is L, interest rate is 2%, 0.02, and then time is 5 years. So we have L multiplied by 0.02 and then multiplied by 5. So when we add the two of them up, it's $750. Now we want to simplify this equation a little bit before we do the next part. So when simplified, I have 0.2m plus 0.1l equals to 750. Since most students do not want to work with decimals, we're going to multiply each term by 10. So we have 2m plus l equals to $7,500, and that's our equation 2. So next step, I am going to use elimination, because right now in my two pink equations, I can see that L can be eliminated. So if I take the second equation and subtract the first one, so 2m subtracting m, I have 1m left. And then L subtracting L, there's no L left. And then 7,500 subtracting 5,500, I have 2,000 left. So that's why once I use elimination, I have m equals to 2,000, and I have actually solved the amount invested in the medium risk mutual fund right away. Instead of using substitution, using elimination is much quicker in this case. Then I substitute m equals to 2,000 into equation 1. Why? Because there's only one m in that equation. I don't want to multiply 2,000 by 2 if I don't have to. So 2,000 plus L equals to 5,500. When I solve for L, then I have 3,500 as the amount invested in the low risk mutual fund. Now in our textbook, okay, they recommend that we check both M and L by using equation 2 to make sure that we didn't make any mistake. Now I'm going to skip that step for now because we have already covered that and you know how to do it. So let's say I know that my answer is correct after checking. So now I'm going to write down my conclusion. So Ms. Law invested $2,000 in a medium risk mutual fund and $3,500 in the low risk mutual fund. So I remember to write down the unit in the concluding statement, and I also make sure that I'm answering the original question. Now let's look at example 2. Let's say Ms. Law orders math t-shirts for her math classes. There are two designs available. We have fraction t-shirts, and they cost $10 per shirt. And we also have graphing t-shirts, and they cost $12 per shirt. Let's say both prices include tax already. So this order has a total of 65 t-shirts with a total cost of $730. The question is, how many graphing t-shirts are ordered? So step 1, identify what is to be solved. We want to find out the number of graphing t-shirts ordered. However, we don't really care the number of fraction t-shirts ordered. So we need to remember, don't calculate the number of fraction t-shirts ordered. Now step 2, identify the information given to us. We know that each graphing t-shirt is $12 and each fraction t-shirt is $10. We also know that the total cost is $730. Step 3, let's pick out the information we need to solve the problem. So for this question, we actually need everything, so there's no need to pick out the unnecessary information. Step 4, we don't really need to draw diagrams. However, it might be useful to generate a table of values for those of you who are confused. So we have t-shirt type. That's one category. And then we have cost. And then we have the number of t-shirts ordered. So these 3 topics, or headings, they are given to us in the question. So the t-shirt types, we have graphing t-shirt, and the cost is $12 each. And then we don't know how many were ordered, so that's unknown right now. And then we have the second type of t-shirt, the fraction ones. So the cost is $10 each, and we don't know how many were ordered, so that's unknown as well. And then what is the third column for? That's for the total. So if we look at both graphing and fraction t-shirts, then the cost, we know that is $730 in total, everything included. And we also know that there are 65 t-shirts being ordered. So this is our table of values. So this table is going to help us generate our equations. Because right now, when you look at the number of t-shirts ordered, we have 2 unknowns. So that's going to be, let's say I use G for graphing and F for fraction. So I know that G plus F is 65 in total. And then I just need to work those unknowns into the cost to get the total of $730. So step 5, we want to write down our let statements. So based on step 4, we have pretty much good idea of what to do with these variables. So we have 2, and we're going to use the total number of t-shirts and the total cost as the 2 equations. And to calculate the cost or the total cost of each type of t-shirt, we have to multiply the number of t-shirts ordered by the cost of each t-shirt. So if I have G number of t-shirts ordered and the cost is $12 each, then the total cost of my graphing t-shirt would be 12G. For the fraction t-shirt, because I use F as the variable, then I have to multiply 10 by F to calculate the total cost of the fraction t-shirts. And then when I add those 2 together, I am going to have $730. So when we solve the variables in step 7, we have to remember to only solve for the number of graphing t-shirts. So we need to remember that we don't want to solve for the number of fraction t-shirts at all. So we want to avoid solving for the number of fraction t-shirts. Let's put everything together. Let statements. Let G be the number of graphing t-shirts ordered. I put G first because I'm reminding myself that I need to solve for G only and not F. And then F is the number of fraction t-shirts ordered. And then my equations. First one is G plus F equals to 65. So the total number of t-shirts is 65. So I add G and F together. And that's my equation 1. For the second equation, I need the total cost based on the cost of each type of t-shirt. So graphing t-shirts are $12 each. So it's 12G. 12 multiplied by G. And then the number of fraction t-shirts is F, and the cost of each is $10, so it's 10F. When we add the two of them up, we get $730. So that's my second equation. We can use either substitution or elimination to solve this question. Of course, we can use graphing too, but let's not do it in this case. We're going to try to use the method of substitution first, and then we will use the method of elimination to do this question again. So when I use the method of substitution, I need to be careful that after substituting, I have only G left and not F. So in order to do it correctly, I need to isolate F first. So F is going to be 65 subtract G when I use equation 1 to do it. And that's my equation 3. I don't really want to use my equation 2 to isolate F because that means I have to divide by 10 afterwards. Using equation 1 is a little bit more efficient. So then I am going to substitute my equation 3 into equation 2. So my equation 2 is 12G plus 10F equal to 730. So I am going to take the F away, and then I am going to replace that F with 65 subtract G. So that means I have 12G plus 10 multiplied by, in brackets, 65 subtract G, and then the whole thing equals to 730. So from here, I'm going to expand. I have 12G plus 650 subtract 10G equals to $730. And then I am going to collect like terms. So I have 12G subtract 10G, I have 2G left. And then I have 730 subtracting 650, which means I have 80. When I solve for G, I have 40 because 80 divided by 2 gives me 40. So therefore, Ms. Low ordered 40 graphing t-shirts. We do not have to calculate the number of fraction t-shirts at all. Okay, we have completed answering the question. Now, let's look at how to do the same thing using the method of elimination. So we still have equation 1 and equation 2. They look exactly the same as before. First, I am going to multiply my equation 1 by 10. So I have 10G plus 10F equals to 650. That's my equation 3. Now, how do I know I want 10 and not other numbers? Because we want to eliminate F. And in equation 2, the coefficient of F is 10. In equation 1, the coefficient of F is 1. So the common multiple of 1 and 10 is 10. So it's easier for me to multiply equation 1 by 10 so that we can isolate or eliminate F after. So I am going to use equation 2 to subtract equation 3. This way, I can avoid using negative values. Because when I'm checking right now, I have 12G subtracting 10g, that gives me a positive number. And then I have 10f, subtracting 10f, that will give me the 0 that I'm looking for. And then I have 730, subtracting 650, and that is going to give me a positive value. So this is why I do not want to do it backwards by taking equation 3 and subtract it by equation 2. Of course, if you do it, you will still get the same correct answer at the end. But if we don't have to use negatives, why not? So 12g subtract 10g, I have 2g. The f's will be cancelled. And then 730 subtract 650 is 80. So then I divide both sides by 2. I have 40. And so Miss Law ordered 40 graphing t-shirts. And we're finished with this question. Let's look at example 3. The length of a rectangle is 4 times its width. The perimeter of the rectangle is 30 centimeters. What are the dimensions of the rectangle? So before we solve this word problem, let's review vocabulary and properties of rectangles. So if we want to calculate the perimeter of a rectangle, okay, perimeter refers to the outline or the boundary. Okay, so please think about that's the fence around a garden. So P for perimeter equals to 2 multiplied by bracket the length plus the width, or the perimeter equals to 2 times the length plus 2 times the width. Either equation is correct, or both of them are correct. Now, if we ever need to find area, which is not this case, then we use a different formula. So area refers to the space inside the boundary. So think about the space you have inside that garden to plant flowers. Okay, we're not talking about the fence anymore. So area equals to length times width. Now the word dimension or dimensions refers to, in this case, the length and the width. The length refers to the longer side of the rectangle, and width refers to the shorter side of the rectangle. Sometimes in textbooks, you might see that the length and width are interchanged, but the textbook is trying to do other things at the point. Usually when we're solving word problems, when you see length, it means the longer side, and width, it would be the shorter side. So let's get back to our question. Step 1, identify what is to be solved. We want to find out the dimensions of the rectangle, so it means that we have to find both the length and the width. Step 2, we want to identify the information given to us. So we know that the length is 4 times the width. That's going to be one equation. We also know that the perimeter is 30 centimeters. So the formula for finding the perimeter is going to be our second equation. Step 3, pick out the information we need to solve the problem. We need everything, so there's nothing to be skipped. And then step 4, if you want, you can draw a picture of a rectangle if it helps you visualize it. If you don't really need it, in this case, that's okay. And then for step 5, then we want to write down unless statements. We have 2 unknowns, so we are going to use 2 variables. So the 2 unknowns are the length and the width, so I'm going to use L and W. And then we're using the relationship between the length and the width as one equation. And then we use the perimeter formula for the second equation. Now let's put everything together. So first, my diagram. Okay, length and width of the rectangle labeled. And then my let statement. Let L be the length of the rectangle. And let W be the width of the rectangle. L equals to 4W. That's my equation 1. That's based on that the length is 4 times the width. of the rectangle. Second equation, I have 2 multiplied by the length plus width equals to the perimeter, which is 30. So instead of using the formula the way we saw on the previous slide, on a few slides ago, instead of writing 30 equals to 2 bracket L plus W, I want my variables to be at the left-hand side. So I switch the order of the two sides. So there are different ways to do this question. I am going to substitution right away. I am not going to expand equation 2 first. I am going to substitute equation 1 into equation 2. So L is 4W. So I'm going to substitute that. So first, I write down my equation 2 bracket L plus W, close bracket, equals to 30. And then I am going to replace the L by 4W because that's what equation 1 says. And then I am going to simplify inside the bracket. 4W plus W is 5W. So I have 2 multiplied by 5W equals to 30. I expand, I have 10W equals to 30. I divide both sides by 10. I have W equals to 3. And that's the width. Next, I want to find out the length. So I substitute W equals to 3 into 1. So why do I pick equation 1? Because it's easier to work with than equation 2. I have L equals to 4W. When I put 3 into W, it means I have 4 multiplied by 3. And so I have 12. So that's the length. So then next step, I just need to write down my concluding statement with the correct units. So the length of the rectangle is 12 centimeters and the width is 3 centimeters. So that's the end of the examples for today. Thank you for watching.